Hello everyone, my name is Arun Goud. I am from Mahatma Gandhi Institute of Technology, 4th year ECA. I am going to present a project of microwave oven during the Emertxe internship. Here the table of the contents. What is microwave oven? Introduction to C programming, requirements, embedded systems, microcontroller and microprocessor, Pixim Lab, CLCD, matrix keypad, ISO, timer, project implementation demo. What is microwave oven? Microwave oven is used to preheat food using microwave, which is of form electromagnetic waves. There are several modes in various microwave oven. We are going to implement four modes: micro mode, grill mode, convention mode, start mode. Uh, there are four modes. Micro mode. This mode is used to cook food in a traditional way. It uses a maximum power of 900 watts. In this maximum time that you can set for cooking only 60 minutes. Grill mode. This method is used to cook meat and bread. It works as a micro mode, but the purpose is used to cook and bread. User can set the time as per the cooking time of meat. Convention mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements. Here there are 3 minutes is our wish. In our project we choose the 3 minutes. You can choose whatever you want. After preheating is done, after preheating is done, then the whatever we applied the temperature, that heating is applied slowly, gradually increasing. Directly it does not go. If we enter the 45, it does not go to the 45, slowly increasing to the 45 degrees. That the preheating will be helped. Start mode. The start mode is used to start the function by user. uh, to starting any function by the user, start mode is used. Introduction to the C programming. Before entering into the internship, we learned something C programming basics. What is functions, what is variables, strings, operators and operations, conditional statements, loops, storage classes, arrays and pointers. What are the requirements to implement the project? Basic, we have knowledge on the embedded C. MPLAB IDE, it is a software. We run the code in this MPLAB IDE only. X8 compiler, it is a compiler which runs the microwave oven code compiling purpose. PiximLab, it is a software. Uh, in this software only we can see the outputs of grill mode, four modes: micro mode, grill mode, convention mode and start mode. Embedded system. First of all, what is meant by embedded system? Embedded system is a combination of any hardware and software which is intended to do a specific task. A general purpose system (GPS) is used to perform a large number of tasks, where areas and embedded system (ES) is used to perform a specific task. Two types of embedded systems. There are four types of embedded systems: standalone system, real-time system, network system, mobile systems. You can see the components of embedded systems: memories, outputs, other devices, input devices. First of all, what is meant by standalone system? Standalone, it consists two types: slave systems and independent systems. Slave systems. These systems are not intelligent, even though these are embedded systems. These embedded systems cannot take action by their own. Example, semi-automatic washing machine. Independent system. These systems can take action by their own. Example, Google car or Tesla something, so on. Real-time systems. These systems are time-bound systems which will take action on specified time. Failures in these systems are not acceptable. Example, hard real-time, firm real-time, soft real-time. Examples: airbag system, network system. These systems which are connected to the network. Example, home security system. Fourth one, mobile systems. The systems which are mobile are called mobile systems. Example, robots and our mobile phones also comes under these mobile systems. Embedded system. This is the basic structure of the embedded systems. And software, which software is used Both hardware and software is combination is known as embedded system. The below part is hardware and above part is the software. In hardware, there are few components which are essential: memories, FPGA, microcontroller or microprocessor. We use the DAC and ADC for the conversion purpose. Input is always analog purpose. The microcontroller understands only digital languages, zeros and ones. That zeros or ones are converted by the ADC, analog to digital conversions. Sensors are used to sense the signals. Actuators, which are the outputs. Example for the sensors are eyes. Actuators is hands and legs. Uh, how to choose an embedded system? We can choose embedded system by their characteristics. There are some characteristics: low power consumption, cost efficiency, cost efficient use of processing power, reliability, efficient use of memory. Next, microcontroller and microprocessors. Some of the small informations of microcontroller, microprocessor, an integrated circuit which is capable of being programmed to perform a specific task. It has design restrictions such as memory size, I/O capabilities, peripheral functions, etc. Choose a microcontroller based on the application's performance, price, availability of tools, and special capabilities. Microcontrollers versus microprocessors. Microcontrollers, all components in a single chip. All components are placed in a single chip. Less flexible, less design complexity. Microprocessor, all components are assembled. More flexible, more design complexity. Here you can see the microcontroller diagram, microcontroller and microprocessor circuits. PIC architecture. It is the structure of the PIC. We have used PIC16F877A as a microcontroller. Uh, we used LCDs, buzzers, and so many things. Current syncing and current sourcing. Current syncing means microcontroller acts as input device. Output will be given by the microcontroller. Next, current syncing. The output will take into the microcontroller. Um, in current sourcing, microcontroller acts as input device. Current syncing, microcontroller acts as output device. CLCD. CLCD means character liquid crystal display. In Pixim Lab, there are two types of displays: 16:2 display, 16:4 display. It displays the ASCII character and some special character. It does not commonly use a display because it is more costly compared to other displays, and it consists of some peripheral and two types of communication modes: 4-bit mode and 8-bit mode. Here you can see the tactile switch. It is a bouncing circuit. If you press it, it will activate, and some time it will be deactivated. There are two types of tactile switch. One is pull up and one is pull down. If we press pull up, it will be 0. If we does not press, it will be high. In pull down, if we press, it will be 0. If does not press, it will be 0. Tactile switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and enter the time. In our project, this switch will be produce a bouncing effect when a switch is pressed. MKB, Matrix keypad. This is a keypad in which number of tactile switches are connected in a row and column concept. This is used when more number of users inputs are required and still want to save some controller I/O lines. These keypads are most commonly used in telephones, calculators, digital lockers, etc. Both in Matrix keyboard we will use tactile switches for pressing the purpose. If we press a key, the row and column will be activated and ASCII code will be generated that will be sent to the LCD, that will be sent to the microprocessor, and it will be converted as zeros and ones that will be given to the CLCD. Interrupts. Interrupts are the fundamental concepts in a computer systems and microcontroller microprocessor architecture. They are mechanisms used to temporarily stop the normal execution of a program or process in response to an event, signal or condition that requires immediate action. PIC16 FA77A has 15 types of interrupt sources. Interrupt service routine and interrupt service routine ISO is also known as interrupt handler. Interrupt subroutine is a specific section of code or subroutine that is executed in response to an interrupt event. Next we go to the polling. It is a process where the computer or controlling device waits for an external device to check the read lines or states, often with a low level architecture. Disadvantages of polling: loss of events may occur during polling, poor response, less power management. Next, interrupts are classified into two types: hardware interrupt and software interrupt. In hardware interrupt, there are two types: maskable and non-maskable. Non-maskable is also known as spurious interrupt. Maskable interrupt means it does not it wait for some of the time. If the interrupt came to the microprocessor, it can be wait or it can be executed immediately or not. um, in non-maskable means it executed immediately only. ISR, we have discussed just now only. ISR means interrupt service routine, and ISR is a software routine that hardware invokes to an interrupt. ISR attend to the request to an interrupting sources by clearing the interrupt flag and should save register content that may by the code in ISR. It must be terminated with the instruction RET. When an interrupt occurs, the MPU completes the instruction being executed. Then it disables global interrupts enables. Place the address from the program counter on the stack written from the interrupt. Timers. Timers is also an important concept. Timers is an important applications in embedded systems which are default peripheral, which maintains the timing of our operations in sync with a system clock or external clock. It may applications such as measuring time, generating delays, uh, etc. Timers or counters. Timers are also acts as counters. Timers or counters is a software designed to count the time interval between the events. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be prescale or maybe 1:1 or 1:8, etc. Modes of timers or counters: PWM or pulse generator. Let's get into the project demo. Before going to the project demo, we have to know we implemented the four types. We implemented the four types modes: micro mode, grill mode, and convention mode and state mode. Let's go to project demo. First we have to reload the project. uh, there are four modes: micro mode, grill mode, convention mode, and start mode. To see the micro mode, we have to press the 1. Now I will press the 1. You can see the micro mode will be turned on. It takes the power 900 watts. Now we can set the time as per our wish, but maximum time is 60. Now I am pressing the keys, tactile switches from the matrix keyboard. I am taking the 30 seconds, and there are two keys, clear and ash. um, Star is used for the clear and ash is used for the enter. If I press ash, it will be started. You can see the microwave oven has been started. The fan is rotating. You can see the time will be decreasing. If you press the 6, it will be go to the home. To stop, we have to press the 5. Next mode, grill mode. In grill mode, we have to set by pressing the 2, we enter the grill mode. We can set the time, seconds and minutes also. I'm just setting the time 1 minute 30. First I press the 30 30 0 and 1 for 1 minute. Now I am pressing hash to enter. You can see the oven has been started. You can select 4 or 5 or 6 to start, pause, stop. If we press 4 again, it will go to the back from starting. Now I am pressing the 6. Now we will see the third mode, the convention mode. If we press 3, it goes to the convention mode. Mainly convention mode is used to preheat purpose. Now I am pressing the 3. And we have to choose the temperature. I'm entering the 45 degrees. Next I'm pressing the hash tricks. Now you can see the 180 seconds because we have chosen the 3 minutes preheating. 3 minutes means 180 seconds. After 180 seconds it goes to the 45 degrees preheat. Now we can go back by pressing the reset. By pressing the reset key, it go back to the normal mode. It shows 4 mode. Fourth mode. By pressing the fourth, we go into the start mode. By default it chooses 30 seconds. If we press 4, it incremented by 30 seconds. Let's wait. Screen will be present on LCD. This is the project. This is a project I have done in internship. Finally, conclusion. Microwave processing technology requires to learn and understand. Microwave oven will update according to the technology, and most likely candidates for future production scale applications will take full advantage of the unique characteristics of microwaves. Microwaves are widely employed in modern technology, including point-to-point communication lines, communications, etc. Overall, we observe working of different modes in microwave oven using PIC 16F8778 microcontroller in PIC Sim. Finally, I thank to the Emertxe team for giving the wonderful opportunity. Thank you everyone.